So today we're talking about 2.1c, the quotient rule, much like yesterday's lesson, the product rule. If you felt confident with yesterday's lesson, today you should feel pretty good too. It's a very similar idea. So let's go ahead and get into it. Bless you.
She told you. Correct. They're all correct. Watch. Oh, what? This is mine. Huh?
Audible, you good?
No, that's mine.
I thought they were mine.
You got a notebook, sir?
Huh?
You got a notebook, right?
What is that?
A notebook, like to take notes?
Yeah.
Okay, let's get it out. We're starting notes.
Do I put these in the basket?
No, I'll take them. Just give me a second.
Never mind.
I think I left my notebook in PE.
Your math notebook?
Yeah.
You don't have it in your backpack?
I'm being dead serious. Wait.
Okay.
Is that downward?
Downward is what it says, yeah. Thank you, man.
That one.
Yeah, go for it, buddy. Thank you.
Okay, where?
Come on up, Kenny.
Should I just use paper for today?
That's a better idea. I'm gonna post the notes anyway.
Well then, I'm gonna just wait and do them?
No, I still want you to take them
Because I
down. So
can't
you,
put them in my notebook if I do it on paper.
you would just recopy them down.
Wait, what?
What page?
2.
Oh,
I have paper today.
Oh,
Page 2, right?
Yeah. I couldn't put it in my notebook.
Oh,
well, if you could,
okay.
do you have a composition of them? Like a smaller one? Or do you have one with the metal one? Oh, then yeah, you should be able to like type the border around it. Do you want this scrap paper or do you have All right, so the quotient rule states that if two like bases are being divided,
P2.
then the quotient is just the same base with their exponents subtracted downward. By subtracted downward, I mean the numerator exponent minus the denominator exponent. Let's see what that looks like real quick. If we have 4 to the 5th power over 4 to the 2nd power, our quotient, or our answer, right? Quotient just means the result of division. Our quotient is going to be the same base, just like yesterday. Keep the base the same. But now instead of adding the exponents, we're going to subtract them. We have to make sure, though, that we're subtracting downward, meaning top number minus bottom number. So we'll never get 2 minus 5 if our problem looks like this. We're subtracting downward. Okay? Five minus 2 gives us 3, so our answer is 4 to the 3rd. Pretty much the exact same thing as yesterday, except instead of multiplication with addition, we're doing division with subtraction. Yeah, look at our definition from yesterday. If two like bases are multiplied, then the product is the same base with their exponents added. Now we're just doing the inverse of that, which is dividing with subtraction. So if we have example B, we've got y to the second over y to the sixth. Y to the second over y to the sixth. Our quotient is going to keep that same base, y. And then we're going to subtract downward. So what is our exponent up here going to look like? Noah? Good. What's the what are we going to set up before we get to the answer though?
2 minus 6.
There we go. 2 minus 6. Not 6 minus 2. Always subtract downward. Top exponent minus the bottom exponent. And then Noah says 2 minus 6 gives us an exponent of negative 4. So now we're going to add in our 2.1a lesson. And this is not going to be our final answer anymore. We always want to have positive exponents in our answer. So how can we make y to the negative fourth have a positive exponent? Azalea, you got it? What's that? Make it into a fraction, exactly. And then what are we going to do with that fraction once we have it in a fraction? We're going to flip it, right? I heard someone say it. We're going to flip it. So this will turn into y over 1 to the negative 4, which, once we flip, turns into 1 over y to the positive 4. And that is our final answer. Okay, so no more stopping right here. Now that we're comfortable with 2.1a and our negative exponents, I want you to go ahead and simplify them when you see them. Okay, but obviously don't do it until the very end, your last step. You don't want to do it too early. All right. There you go. I just added in use 2.1a to simplify negative exponents if you need it. All right, let's take a look at example C. Example C, if we've got x to the negative 3 over x to the negative 5. Oh, that's okay. Just grab it. X to the negative 3 over x to the negative 5. Again, we're just going to subtract downwards. So x to the negative 3 minus negative 5. Now, yesterday we saw plus signs next to minus signs, right? And they formed a minus. What are two minus signs going to come together and form? Azalea? A positive, right? So let's rewrite this as x to the negative 3 plus 5. And what's our final exponent going to be on our answer? Noah, 5 minus 3? 2. Positive 2. Just like that. Thumbs up if you're with me so far on this. Okay, only a couple people. That's all right. We got more. Real quick, let's do one more example, and then we'll talk about why this works. So example D, let's say we've got 4 over 4 to the 5th. Hello. So if we have 4 over 4 to the 5th, thank you. Oh, Noah, your question has been answered, sir. Back to school night papers. I'll get them out in a sec. While you guys are working, I'll pass them out. So, anyone planning on going to back to school night tonight?
No, I have to.
Who's that?
Couple people. You got practice? Okay. Your parent can still come.
I don't want them to, but I think.
That's all right. If I see him, I'll meet him.
No. Just tell them that I don't want to.
Okay, gotcha. I'll tell him the truth.
You say I'm telling the truth.
Yeah, that you're the greatest ever.
Tell my mom something very good about me.
Don't worry, I'll have all kinds of positive things to say. So, let's come back together. Sorry about that.
Negative things, so it should be the teacher that says positive things, you know?
Gotcha. Okay. I can only say positive things if I see positive things, though.
You not know who saved us?
Okay? Don't give me anything negative to say to your parents,
She's a fun.
either tonight or at any time.
She's a fun.
All right, listen up. We got 4 over 4 to the 5th. Again, what's that secret exponent on the 4 there, Mason? 1, right, thank you. We got that invisible 1 that we can't forget about. So if we do the quotient rule, we're going to have 1 minus 5. Right, not 0 minus 5. 1 minus 5. Don't do that, please. Let's focus. And then what's 1 minus 5 going to give us? 4? Negative 4. Come on, guys. We did an integer review. If we start at 1 and are subtracting 5, well, can you have $1 in your bank account and then spend $5? No, because you'll have negative $4. And that's not going to work.
Wait, not if it's a what you call it account.
Credit?
No, certain account where like you can't go past.
Oh, I know what you mean. Yeah, that's true. But that's all right.
You can't have negative 4. Your car's just gonna decline.
Yeah. That's typically how it is. So, we got 4 to the negative 4. Again, we're not done yet. We're almost done. We got to make this positive by doing 1 over 4 to the 4th.
To the 4th.
All right? Questions on that one? Because that's going to come up on IXL and on the worksheet, so I want to make sure we're good. All right, let's take a look at why does this work. Just like yesterday, we learned the shortcut, but we got to know why we can even use a shortcut. Let's go ahead and expand example A. So we add 4 to the 5th over 4 squared, right? Yeah, 4 squared. So we're taking another look at example A. We're going to see why this works. So if we wanted to expand this out, if we wanted to expand 4 to the 5th power out, what is our numerator going to look like? You got it? Theo? No? Noah?
4 times 4 times 4 times 4 times 4.
Perfect. 4 times 4 times 4 times 4 times 4. 5 4s on the top. How many 4s on the bottom?
2.
2, right?
You know I had beef with 0. I had beef with 0.
So 4 times 4 times 4 times 4 times 4 over 4 times 4. Everyone agree with the way we expanded that out? Doesn't change anything about our fraction, right? Just gives us a better look at what we got.
How many 4s are there?
There's 5 on the top, 2 on the bottom.
That's a lot of 4s.
So remember, when we have common factors in the top and the bottom of our fraction, right?
Yeah.
So funny.
What can we do when we have a matching pair of factors? Azalea? We can cross them out. So let's take this first pair of 4s, circle them up, and then this second pair of 4s, circle them up. And all 4 of those 4s are going to cancel out. Boom, 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 boom. So we're going to cancel common factors from the top and the bottom. How many 4s does that leave us with on the top? 3, right? 4 times 4 times 4. What do we have left on the bottom? Do we have anything left on the bottom?
Yeah.
No. So is it 0?
No. 1.
No, it's 1. We can't have a 0 in the denominator ever. 4 times 4 times 4 over 1. That's just equal to 4 to the 3rd power. And when we use the quotient rule in example A, what answer did we get? 4 to the 3rd power. We just subtracted 5 minus 2, right?
Mr. Kirk,
Yes, sir.
can I go to the bathroom?
Yeah, go ahead and sign out. We're just about done anyway. But no. Oh, actually, we have one more thing, but that's fine. Go ahead. So, when we expand it out, we can cancel from the top and the bottom. And that's how our quotient rule basically works. All right? So now let's do a little bit, or let's do something a little more challenging. Let me find what I want first. Let me pull one from the IXL. Okay. Let's do 8 to the 4th times 8 squared over
How much more do we have?
8 to the 3rd.
Because I'm bored. And I'm gonna.
Oh, I know what we need to do. Okay, I got it.
Yeah, so with this example, all we're going to do is combine yesterday's lesson, or yesterday's steps, with today's steps. Okay? Guys, let's focus up, please, especially right here in the front. Okay? So, first, let's use the product rule in our numerator. Right? We got like bases being multiplied. So the first thing we're going to do is add these exponents up. 8 to the 4 plus 2 over 8 to the 3rd. And that is the product rule. That gives us 8 to the 6th power on top over 8 to the 3rd. And now that we've condensed our two terms in the numerator, now we can use the quotient rule to bring this down into just one base of 8 to the power of 6 minus 3. So if you see something that looks like this on IXL, you may get confused because there's a lot going on. Just take it step by step. Solve the product rule first, and then you can solve the quotient rule. And here you would get what? 8 to the 3rd power. Exactly.
So much.
So this right here was the quotient rule.
Okay.
Okay, so that's basically how you would combine the product rule and the quotient rule. Questions on that?
Nope.
Beautiful. Time we got 25. This class is so long.
No, it's not. Actually, yeah,
It's second period.